Good morning, everybody. This is Carl Griffith from Graybar, and we're glad that you're here with us today in our G2 Talk seminar series with these presentations the third Thursday of every month concerning issues and concerns and tips of the trade in the data center space. Just for those folks that don't know Graybar very well, I'd like to go over just a little bit about what we do and what we're all about. Graybar is a distributor, and we provide solutions into the data center, whether it be a newly constructed data center or whether it be one that's being rebuilt or redesigned. Our mission statement is written on the screen there. Graybar helps our customers power, network, and secure their facilities with speed, intelligence, and efficiency. And in this particular case, the facility is a data center. Our offers include electrical power distribution, communications connectivity, cooling, security, and I mean physical security there, lighting, automation, and services. Now, for those that saw the invitation, you see that we're offering a cup of coffee for the first 50 people that came up on the seminar today. And stay with us. You'll get an email in your email in basket later today or early tomorrow for a cup of coffee. You can take that to a large national or global coffee establishment and exchange that email for a cup of coffee, and we would be that's our gift to you, and we thank you for attending our seminar today. Our speaker today is Jay Myers from Legrand Ortronics. Jay's a subject matter expert in the area of communications connectivity and data centers. He trains people around the company and globally, for that matter, with connectivity training as well as data center training. He is a subject matter expert in training. I've known Jay for 20 years or so, and I can tell you his presentation, I heard it a little earlier, is just absolutely fantastic, where he discusses the concept of layer zero and then what solutions are available to us in the data center from a layer zero perspective. So without taking up too much of Jay's time, I'd like to pass the baton on to Jay and thank him very much for being part of our G2 Talk seminar series today.
Okay, thanks, Carl. Welcome, everybody. The topic of our presentation today is that to get the best performance out of your network and your data center, it assists you in managing the environment that your network exists in. That includes the physical environment, racks, cabinets, cable pathways, cable management, and also the environmental temperature and the amount of humidity in the air in the data center. Now, if we polled all of you and asked you to make a list of your top 5 concerns, the things that keep you awake at night in operating your data center, my guess is that probably none of you would list cabling or racks and cabinets in your top 5 worries. But this presentation, I hope to point out that fairly simple devices, all completely passive, can really assist you in the things that you do consider important. My guess is that for most people, power and cooling would be near or at the top of your list. Useful use of your space, efficient use of your space in the data center because it's expensive space. Reliability is always an issue, and so forth. So here are the issues that we hear most from our customers. So how can this fairly simple, low-tech end of the data center infrastructure actually assist you in managing these? The power consumption in data centers has really exploded over the last decade. I think a lot of this has really sneaked up on us in the industry. 15 years ago, if you went to Bixby, you would hear no presentations on cooling. And for the last several years, every single Bixby meeting has had presentations on this. You can see why cabling is fairly low on the totem pole. We're a pretty small budget item. Power for most data centers is the most expensive line item in the budget. As another issue, there's a misalignment between the infrastructure that we provide, the cabling, and electronics and software. Most of that gets replaced on something like a 5-year schedule. Our cabling and infrastructure is expected to last much longer, 10, 20 years. It makes the design of it much more challenging. I'm sure all of you have seen the 7-layer model, the ISO model. This has provided a good roadmap for our industry in developing our networks over the last 30 years or so. It's taken us from 10 megabit Ethernet to now 10 gigabit and even beyond to 40 gig and 100 gig. But one thing this 7-layer model has never provided is a good foundation to support all that. And that's what the layer 0 message is. That the infrastructure layer below this is becoming more and more necessary to get the performance we need out of our networks because we are demanding more and more from this bottom layer, our cabling and physical support. I think a good sign is that Cisco has actually taken an interest in this. 10 or 15 years ago, Cisco wasn't interested in talking about cabling, racks, and cabinets. But now they're coming out with white papers declaring that this is a crucial part of the infrastructure. So here's the kind of current state of the art in most data centers, having hot aisles and cold aisles alternated. This is a step forward. This is our first baby step as an industry. 15 years ago, everything was just pretty random. So this helps. This is an improvement in efficiency, but it's incomplete. If we stop here, it's like going home on a hot day, cranking your air conditioning on full blast, but leaving all your doors and windows open. So as we go through this, what we're going to do is just one by one go around and, in effect, close those doors and windows to improve the efficiency of our cooling in the data center. I think over the next 10 years, you'll start to see more and more passive control being used in data centers. Most large data centers already are. I think there's a big opportunity for savings and efficiency. So how does this work? How can this simple, low-tech end of the network actually help me, a data center manager, with what I'm concerned about? So we're looking down on 3 Cisco switches, ventilating right to left, installed in cabinets with ventilated doors, front and rear. And these are installed according to Cisco's instructions. And as you can see, the exhaust from the first one goes right in the intake of the next one. And before long, your 65-degree intake air is now heated up till it's far too hot for the equipment. So what do we do about it? And maybe we should put the sides back on the cabinets. So we reinstall the sides in the cabinets. Then some of the hot air is going out where we want to the hot aisle, but still a lot of it circulates around because we're really not controlling where it's going. So it dilutes the cooling air coming in to the right side of the switches, and we still have too hot a situation. Now, when a data center manager notices this, probably their first inclination is to walk over to the air conditioning units and crank down the temperature, and that'll help. But of course, that dramatically raises your electric bill, which is already high. So instead of doing that, why don't we just do a little bit of engineering here, excuse me, and install some diagonal baffles from the front corner of one switch to the back corner of the next switch down. So this guides the cool air into the equipment from the cold aisle, and the hot exhaust air is exhausted out into the hot aisle, but it's blocked from circling back around and diluting the cool air going into the intake. So this allows us to raise our ambient temperature back up, saves on electricity, but still keeps our equipment at the temperature that we want. Now, ASHRAE, who's acknowledged as the expert in air conditioning, has, over the last few years, dramatically changed their recommendations for operating temperatures in data centers. Their earlier recommendation was down to 68 degrees, pretty cool. But they have recently raised that up to 80 degrees. And that's a very dramatic difference in the amount of cooling required, and it makes possible huge savings. They are acknowledged and recognized as the experts here. So even if that seems strange, I think it's pretty safe to rely on their recommendation. This is going to require all of us in the industry to educate ourselves a little bit because we're not used to that. I've talked to a couple co-location data center managers who are giving prospective customers a tour of the data center. They've had customers say, I'm not going to put my equipment in here. It's too hot. It's 80 degrees. So even though the data center manager is convinced and saving a lot of money by running at 80 instead of 68. I think our whole industry needs to be educated in this. Here's the axis across the bottom is temperature and up the side is humidity, and you can see how their envelope of recommended temperature and humidity has expanded greatly. This makes possible huge savings in electrical consumption. According to Mark Monroe, the director of sustainable computing at Sun Microsystems, you can save 4% in your energy costs for every degree upward change in ambient temperature. Every data center is different, and it's hard to predict exactly without a computer computational fluid dynamics study. But many of our customers anecdotally have told us they can raise their temperatures 10 or 15 degrees and still have acceptable equipment temperatures. That's a huge savings. The colder your set point is today, the more potential there is for savings. Okay, so how does something like a rack or a cabinet help me with reliability? Our expectations of reliability are much different now than they were 10 or 15 years ago. 15 years ago, the computer goes down, everybody kind of has a chuckle and say, well, we get the afternoon off, ha, ha, ha. But today, it's very serious. We don't expect any downtime. I don't know if anybody remembers last year, BlackBerry's network was down for about an hour. It was front page news. Oh my gosh, it's the end of the world. So our Ethernet budgets, as you can see, have dramatically shrunk. This is the amount of loss allowed in the cabling. And even a single bend in an Ethernet jumper there can create 3 or 4 dB. So that single bend can take down your Ethernet link. Now, nothing's broken. Technician can find that, straighten it out, no harm done. But if you have a customer and you're a co-location data center operator and they've had an outage, that's very upsetting. And they expect for all that money they're paying you to keep them up and running. So just simple bend layer, zero layer or layer zero bend limiters, nice wide fingers in your cable managers can prevent that. These copper ports also can be at risk. Our customers tell us that the ones most likely to fail are the ones on the end, where the patch cords can be tugged on by technicians. They've got a 12-foot jumper or patch cord, and they really need a 15-footer. They kind of tug on it, and it pulls that port straight sideways. By putting just a solid piece sticking out from the front of the rack before the fingers break out, that can help prevent that. It can keep the technician from pulling that straight sideways. So how can we save space? This is an overhead patch panel that bolts to the side of the cable pathway up above the cabinets. We built these for one customer as a custom item. As soon as other people saw the photos, and they want them, so they're all now in our catalogs. They estimate that they could save 12 to 15% of the vertical space in their cabinets. So what that means is, by the time you put in 7 cabinets, you get the 8th cabinet free, and it doesn't take up any floor space. So these have become very popular. Another benefit to these that we didn't think of, our customers have told us, is that this decouples the scheduling of building out a data center. So these can be installed. The cabling can all be pulled in and terminated on the back of the patch panels here, and then roll the cabinets in and just plug in the patch cords. Speed of implementation is important in many projects. I don't know if I've ever seen a data center project that was not in a hurry. But something as simple as just how your nuts and bolts fasten your racks together can really help. Our racks, as well as everybody else's in the industry, held together with 16 nuts and bolts, 2 at each corner, front and rear. If those are all just loose nuts and bolts, it practically takes 2 technicians with 2 wrenches to assemble the rack and get it square. By injecting plastic around 2 of the nuts at a time at precise spacing, it's now a 1 technician job, and it only takes 1 wrench. So it dramatically speeds up the assembly. Cable fill, and that's in the center there, is at least 30% faster to install than the traditional ladder rack. It also is open, so it allows better cooling of the cables, which is important as we go to more power over Ethernet as well. Okay, so even though this is just simple stuff, this is just bent metal, a well-designed layer 0 can dramatically improve passive cooling. It can reduce power consumption, improve the reliability of your network, improve use of space, and also speed up the implementation. Now, so how do we take the next step in cooling? So now we've looked at kind of at the rack level. Now, how do we look at the entire data center and try to improve cooling here? Most data centers today are still cooled by just flood cooling. Just flood as much cold air as you can get into the room through the raised floor, and hope for the best. What this results in is that the temperature set points are lower than they need to be because you have to keep the very hottest rack cool enough so everything else gets overcooled. Kind of a hidden cost is also humidity set points. The cooling naturally dehumidifies the air, but the common wisdom is that you need to keep the relative humidity up to about 50% to prevent electrostatic discharge, which can damage your equipment. But that cold, dried out air has to be rehumidified just a few feet later, and that's a substantial cost. Also results in having more air conditioning units than you need. If you're having trouble cooling that hot spot there, and you call up your local air conditioning representative, who's your buddy and your expert that you rely on, first thing he's going to say, well, you need another air conditioning unit. That'll be $85,000, please. Also, many data centers are not able to fill their racks all the way up to the top because they can't get cooling air up high enough, so it's wasted space. And also, many data centers are actually limited by the amount of power that they can get. I visited a couple of co-location data centers that were half empty. And I asked them, how's business? And they said, we got people lined up to get in here, but the power utility can't get us any more power. So these are the benefits. If we can control the air better, we can keep the cold air where we want it and the hot air, we can edge up the temperature set points, edge down the humidity set points. Most recommendations now are for 30% rather than 50%. We cool better, protect your equipment, increase the longevity. If we can fill up the racks better, then you use that space more efficiently, and that next 25,000 square feet of build out, we can put that off for 2 or 3 years. That's a huge savings. And most of these are fairly simple devices and easily installed. So the return on investment for most of everything you're going to see here is less than a year. There's not very many things you can put in a data center that pay for themselves in a year. Now, there's kind of an ongoing debate in the industry as to whether it's better to contain the hot aisle or contain the cold aisle. And I think it's a little bit of a false debate because really we want to control both. We want to force all the cold air to go right through our equipment so we get the use of it, and we want all the hot air to go back to the crack unit. Any mixing of that is waste. If we let the hot air flow over top of the aisle and mix with the cold air, we now are diluting that cool air that we spent a lot of money cooling. And a little bit of a hidden cost also is if we let the cold air dilute the hot air and the air going back into the crack unit is not as hot, that reduces the efficiency of those units greatly. So we can use kind of the natural properties of the air pretty easily. Cold air is denser, and if we can close off the ends of the aisles with some kind of door or curtain, that keeps the cold air from just flowing out the end of the aisle. That cold aisle will kind of fill up, like a swimming pool. The hot air tends to be lighter and naturally rises, so as long as we provide a good pathway for it, it'll end up back at the crack unit where we want it as hot as possible. So we really have to manage both. So here's our baseline typical 9,000 square foot data center. It's got 105 racks in it. It's arranged, most of it hot aisle, cold aisle. And this is a CFD study, computational fluid dynamics study, to see what will happen as we go step by step and try to close these wasteful leaks. Okay, so at our starting point, we have 5 racks above 80 degrees, above the recommendation of ASHRAE. That's too hot. That endangers the equipment nose. We have 11 racks that are in the proper range where we want them. And then we have 89 below that range, so they're cooler than they need to be. So they represent wasted money. So first step, every data center I've ever walked in has holes in the floor where holes have been cut for cabling, or the cabling's been removed, and we need to plug those holes up. There in the center you see where it says air plugs. Those are just squishy little cubes. They're surrounded by, or they're covered with flame retardant canvas. They're rated for plenum areas. So we can go around and squish those into those holes and just plug them up. In the past, we and many in the industry have used brushes to help seal those, and those work somewhat. They're better than nothing, but they really don't seal very well around cables. These conform very well and really plug up those holes. The air disruptor you see there is one of the counterintuitive things that we've discovered as we study this more and more. At first glance, you'd think you would not want any obstructions under the floor. But as it turns out, the air coming out of the crack unit supply under the floor is going so fast at the beginning of the aisle that the first 4, 5, 6 tiles don't really get any airflow. The air just blows right by them. In fact, sometimes it even causes the perforated tiles to suck air down from the room back under the floor, which is not desirable. So by putting in this simple flame retardant canvas, filling about half the space between the floor and the raised floor, helps balance out that subfloor air pressure. Just kind of tumbles the air a little bit. It slows it down enough so that it equalizes the airflow out the tiles. We also don't want air flowing through the racks. If the hot air can flow through the empty space in the rack, that dilutes that cold air. So for this, we just need simple blanking panels, as you can see there above that switch. We want this row of racks here to be a solid wall all the way across. Okay, so now we've taken these few steps, and you can see we've now gotten rid of that hot spot that we saw before. And now you see that dark blue in those aisles? That's way cold. That's a lot colder than they need to be. So according to our CFD analysis now, all the racks are below 80 degrees, so that's good. We only have 1 in the recommended range, and we have 104 that are colder than they need to be. So now what do we do here? So now we can take simple curtains of flame retardant PVC, hang aluminum rails overhead, and just clip it to the drop ceiling if you have one. If you don't have a drop ceiling, we have clips that work with Unistrut. And we can seal off the ends of the cold aisles and then have these come down to divide down the tops of the cabinets between the hot aisle and cold aisle. This keeps the air very well where we want it to be. All the cold air has to go through the equipment, and the hot air is not allowed to flow over top of the cabinets and dilute the cold air. Just by installing these, we're able to shut off 1 of the 5 crack units in the data center. This is also very easy to work with overhead obstructions. Most people now want to put their cabling overhead, and this is very easy to work around. So here's our chart now. We've turned off 1 crack unit. Depending on where you are geographically and how much you pay for your electricity, that could easily save you $25,000 a year in electricity. Notice also in the return temperature column, these temperatures have edged up a little bit. So the return air is getting warmer, which is what we want. We want the hottest possible air going back into the crack units. If you have, say, a 20-ton crack unit, and the temperature difference between the supply air and the return air is only 10 degrees, you may only be getting 10 tons of cooling out of that crack unit. But if you can raise that temperature up to 80 or 90 degrees, and by keeping the air from being diluted by the cold air, you may get 25 or 30 tons of cooling out of your 20-ton unit. So that's also a hidden efficiency that's not so obvious. The intake for most crack units is about 6 feet up off the floor, but you can tell if you just stand on a chair, stick your hand up near the ceiling, it's a lot hotter up higher. So if we can extend that intake up into the false ceiling, we can make sure that we get the hottest possible air back to our crack units. If you don't have a drop ceiling, even just extending that up 4 or 5 feet, the air stratifies pretty well. And if you can get that up where the air is hotter, it'll increase the efficiency of your units. Now, so far, all we've done is improve the cooling. But where you start to save the money is when you start edging up your set points. And this allows us to edge those up and still have acceptable temperatures for our equipment. So here's before and after. Now on the right-hand side, you can see that red circle there. We've turned off one crack unit. Those cold aisles are now in perfectly good temperatures, but they're not being excessively cooled. Now, we still have some isolated equipment here and there. Hot spots, if you have one rack or one cabinet that's just full of blade servers, that's going to be a challenge to keep that cool. And some equipment is not even in an aisle. A lot of storage equipment sometimes is off by itself a little bit. So for this, to focus right on that, we can put a portable containment booth. It's just a 3-sided phone booth on wheels, and put it right up against the front of the rack, so the cold air coming up out of the perforated tile inside there just fills right up. Keeps concentrated cooling. It allows you to use the entire rack all the way up to the top. The standard one of this is 24 inches wide, but we can make them 48 or even 6 feet wide. Now, as a result of this, we can now turn off a second crack unit and still have all equipment be in acceptable range, temperature-wise. That's pretty dramatic savings there. And now, as you can see, the return temperatures are up quite a bit, and we've turned off a second crack unit. That's a big savings. Also, a little less obvious, you've improved the redundancy in your data center. When it took all 5 units at full blast to keep your data center cool, then one of them fails, or you have to take one down for service. Now you're putting your equipment at risk. Having 2 extra allows you to rotate them around easily. If one needs to be taken out of service, you take it right in stride. So this has all been completely passive. We have not brought any additional energy consumption into the data center. No fans, whose electricity then would have to also be air conditioned back out. So using fairly simple devices, we can really improve the operation and really save a lot of money. Most large data centers are all using some form of air control. But I think there's a huge opportunity for us now in medium and smaller data centers to add these fairly simple devices and really spread these savings around. I think almost everybody's heard enough about air control that they're pretty convinced that they need to do something, but it's still fairly new in our industry, and a lot of people don't know quite how to go about it. That includes us and our sales forces as well. So I think this is something for all of us to learn, but there are big benefits. One great part about it is you don't have to wait 6 months to see if it's working. You hang these curtains up and plug the holes. You walk in the next day, and it's dramatic. You can tell. So I encourage you to explore this. Just if it gives you a little comfort here, these are all companies using this technology right now. So thank you. Legrand Ortronics is committed to sustainability. This presentation was composed entirely from recycled bits, and no animals were harmed in the presentation in this presentation. So thank you. I encourage you all to type in some questions. We've reserved 10 minutes to answer as many questions as we can.
Thank you very much, Jay, for your presentation. It was outstanding. And again, everybody online has an area on their screen that they're viewing where they can type in a question if they have one. A couple questions came in during your presentation, Jay, and I thought we'd go over them right now. A question came in from Tim. Tim has a raised floor data center, and he's reduced the floor space on his data center. He wanted to know if you had a solution that would allow him to redirect the air away from the raised floor that's not being used. So I don't know, is that a curtain or is that an air dam? How can you block off part of a raised floor that has no equipment sitting on top of it?
Good question. And we've had a couple customers actually do this. They thought of it before we did. Those pillows, those squishy pillows, are available. They're all 5 inches thick, but they're available up to 24 inches square. And they bought enough they were going to build a sheet metal wall under their floor, which would be very expensive and also not very flexible. But these pillows, they just kind of tucked them in between the pedestals, and they fit perfectly, and just seals it right off. And they sealed off the part they weren't using very, very easily. And also, if they need to build out a little bit more space, they're very easy to move.
So you're basically talking about building a block wall, so to speak, but the block wall is made out of these air dams. Now, some of these raised floors can get 36, 40 inches. Is there another solution besides piling up air plugs? Is there something else we can do there?
For that, I think I would probably suggest the air disruptors. The flame retardant canvas. Our standard. We have standard sizes, but I don't think they would be that big. But it's very easy for us to make any size they need. You install them just with tie wraps around the pedestals and the floor. So it's very easy to put in, very easy to move.
Or maybe a combination of both.
Yeah, maybe a combination of both. Anything that's not, doesn't have to be inflexible and expensive and difficult, like sheet metal or building walls and that kind of thing, I think is desirable. And also, just to mention, I don't know if you mentioned it or if I did, everything you saw here are standard products. They're all available from your Graybar rep.
Again, I wanted to remind everybody, if you have a question, go ahead and type it in, and we'll address it in these last few minutes. I had a question, and it's about that three-sided complete containment solution that you spoke about. I think you described it as being like a phone booth, and we can just slide it in front of the equipment. Are there multiple part numbers for that? Is it something that's engineered on site? How is that delivered, and is it assembled on site, or is it come in a box? How does that work?
Okay, yeah, the standard 2-foot wide one is standard as a standard part number for it. It is shipped fully assembled in a box, and it's very sturdily put together. Okay,
and in terms of air, I have another question, and this is my very own question, and it has to do with air curtains. I'm fascinated by this. I think it's a great solution that you have. I mean, we can use those to seal off the end of rows, et cetera. But I've been in some data centers, and I've seen some curtains hanging from the ceiling that just actually went from the ceiling to the top of the cabinet just to keep air from rolling over the top of the cabinet from front to back. Yep. Have you seen solutions like that, or is that a good solution or not?
Yeah, it is, and that's the two places that curtains really give you the benefit. One is to seal off the end of the cold aisle to kind of form a door, in effect, and then to continue that up above the cabinets, all the way down the aisle of the cabinets above, to keep that warm air from leaking over into your cold aisle. And those are the two places where you really want to seal off the air and keep them from mixing. So they work very well with that. Some people trim them with scissors to just come down to the top of the cabinets. A lot of people I've seen just roll them up in case they want to pull a cabinet out later and just leave it on top of the cabinet, and it works very well.
If a customer has a row that's contained, let's say it's cold aisle contained, and we wanted to, or a hot aisle contained, and we wanted to build a hot air chimney. Could we do that for like multiple cabinets and build like a giant chimney that just goes straight up to prevent air from mixing. Have you seen that?
Sure, and we have done custom projects like that for people. There are a couple trade-offs. It's somewhat more expensive. It works very well. In effect, it's a one form of hot aisle containment, but it works best if you're having a kind of a new build out. Everything's going in at the same time. All the cabinets are the same, and you don't plan to move stuff around very much. And I think a lot of people think they're not going to move stuff. I've got it just the way I want it. I'm not going to move anything. But in the real world, data centers grow and change. I think more than most people expect them to, and the chimneys are less flexible. I would say, if you're going to be moving cabinets in and out. So that's the trade-offs. They work very well. We've done them before, but that's the factors I would consider.
Great. Several people have asked about whether the slide deck's available, and the answer is yes. You can contact your Graybar rep, and we can get it to them via Jay. The other thing you need to know is all of our presentations for G2 Talk are archived, so you can go back and get the presentation at graybar.com. Another person talked about the solution that you had, the 0U or layer 0 solution where the patch panel was mounted to the basket tray, and this person wants to know if there's an option with brackets so we can mount it to the top of the cabinet and not just to the tray.
I've seen them mounted on the bottom of the tray and on the side of the tray, and that's a good question. I should know that, and I don't. It would be very easy. We could make if we don't have those brackets, it's very easy to make those. Those overhead racks come in 2-rack unit, 5-rack unit, and 8-rack unit sizes.
All right, I've written down the name of the person that gave us that question, and I'll get back with you later, and we'll chat with the engineering department over at Legrand and see if they actually have brackets available to help with that. Another person asked a question, has there been an ROI study on the solution with that 3-sided phone booth kind of thing? And there's a question about, the same person asked, how expensive are those? Can you give us a rough idea on what that 3-sided solution might cost, and if there is some ROI data?
That's a good question. I don't do pricing, and so I don't know positively, and I hate to just sort of pull a number out of the air, but your local Graybar rep can tell you right away. This is a standard part number, and you can look it right up in your computer. As far as ROI, it's every data center is different, and it's a little hard to predict. The CFD studies can give you pretty good guesses, but those are pretty detailed. It takes a lot of information to put in the computer, and the computer cranks on it for 20 hours to come up with those pretty colored diagrams. I think how it would be determined, or what it would depend on, is how cold you had to keep your data center before using that in order to keep that hot spot within an acceptable temperature range, and how much you could raise the temperature by putting that booth in. It'll tell you pretty soon when you do it. But if you could raise the temperature of the whole rest of the data center by 10 degrees, that would save you a ton of money. And, for instance, in our example there, turning off 2 of the crack units, in a single year's savings just in electricity alone would certainly pay for all the air control that you could fit into that 9,000 square feet.
My friend Lilette from Ortronics indicated to us that there are brackets available to mount those patch panels on the top of the cabinet. So the person that asked that question, the answer is yes, those brackets are available. Another question came in from James, and he wanted to know, have you seen anybody mount Ethernet switches overhead above the cabinet?
I don't think I have seen that.
Okay.
I don't see any reason why you couldn't, but most of the time people want to have their equipment a little bit better protected, and they don't care so much about our patching, our cabling. They view that as a little less sensitive, I think. many data centers now are using top-of-rack mounting for smaller switches and then aggregating them back to end-of-row switches or to core switches. So it's more and more common to see them at the top of each rack. I haven't seen them mounted outside the rack or cabinet.
And this will be our last question because we're running out of time. But Tom had a question about a company called Triad that makes perforated tiles that have some disruptors or baffles in the bottom of the perforated tile. Is there a working relationship between Triad and Ortronics from a layer 0 perspective?
Yes, we do have a partnership with them, and we work together in designing systems for people. Those tiles are very effective and they work very well.
Well, again, Jay, I want to thank you for the time you gave us today. This has been a terrific presentation and well thought out, and it was great. There are some questions that came in, but we're run out of time, and I want to hold true to our SLA and not going beyond 40 minutes. I wanted to remind everybody that if you were one of the first 50 people online, you're going to get an email for a cup of coffee. We wanted to let you know that any of the solutions that were mentioned today are available to you from Graybar. Just contact your Graybar rep, and we can arrange for Jay or a member of Jay's team to come out there and take a look at your data center and evaluate it with you to see how we can help you out. Of course, anybody on the Graybar team would be glad to orchestrate that, and we have several data center specialists throughout the country that can help you with these solutions as well. So stay in touch with Graybar, and we'll be glad to help you with these cooling solutions that were outlined today. We do a G2 Talk seminar every month on the third Thursday of every month at 10:30 Central Time. So we appreciate your time. We wish all of you a wonderful day and enjoy your cup of coffee. Thank you very much.
Okay,
have a great day.